Hello everyone and welcome back to STEAM Aspirations. Today we will be solving problems numbered 7 and 8 of the 2015 AMC 8. So let's begin with problem number 7. We have that each of two boxes contains 3 chips numbered 1, 2, and 3. A chip is drawn randomly from each box and the numbers on the 2 chips are multiplied. What is the probability that their product is even? So let's first look at different possibilities that we can get from drawing chips. So let's just have this column for box 1, the chip we get from box 1, this column for box 2, and this column for the product. And finally, we have one for the parity. And parity is basically whether or not it is even or odd. Alright. Well, so let's do a few draws. So we have that, let's just say we get a 1 from box 1, a 1 from box 2, then the product is going to also be 1, which is odd. Let me just redraw that line. Alright, so now let's try box 1 being 2, box 2 being 2. The product is 4, which is even. Now let's try 2 and 3. It's the product of 6, which is even. Let's just try a few more. Let's just extend these columns downwards. We have, let's just do 2, 1. This is 2, which is also even. And similarly, if we have 1 and 3, this is a product of 3, which is odd. So as you might have noticed, the product is always even if there's at least 1, 2 in the product. And this is because an even number is actually defined as a number which is divisible by 2. So essentially, we're trying to find out the probability that there's at least 1, 2 in the 2 chips drawn. And in order to do this, we can use a method called complementary probability. And complementary probability is basically just finding the probability of an event occurring by taking the probability that the event doesn't occur and subtracting it for 1. So let's say we have an event that has probability P occurring. Well, we can calculate P by taking 1, which is all of the outcomes, minus the probability that P doesn't happen, which I'll denote as NP. So in this case, let's denote the probability E for even, and the probability odd, O for odd. So we know E is equal to 1 minus O. Now what is O? So in order to find O, we can use the multiplication rule. So we know that we have 2 boxes, and in each box we need to choose a chip that is not 2. So in box number 1, we can choose 2 out of 3 numbers. We have 1 and 3, which are both odd, and then there's 3 total numbers. So the number of successes is 2, and the number of total outcomes is 3. And then now we actually have to factor in box 2. So in box 2, there's also 2 successes, being 1 and 3, and there's 3 totals, which are 1, 2, and 3. And this probability is equal to 4 over 9. And now we can actually solve the problem. Since we know odd probability is 4/9, we have that the even probability is equal to 1 minus 4 over 9, which is equal to 5 over 9. Choice E. And we are done with the problem. Let's move on to problem number 8. We need to find the smallest whole number, let's just highlight smallest whole number, larger than the perimeter of any triangle with a side of length 5 and a side of length 19. Now, in order to do this, we need to use the triangle inequality, which states that for any triangle with side lengths A, B, and C, we have that A plus B has to be greater than C, A plus C is greater than B, and B plus C is greater than A. Or in other words, the sum of two sides is always greater than the third. So we have that one of the sides is 5, and one of the sides is 19. And we want to find out the smallest number that's greater than the perimeter, which means that we also need to find the largest possible perimeter. And let's look at each of these three inequalities, letting 5 be A and 19 be B. So let's start with the first inequality. A plus B is greater than C. This would give us 5 plus 19 is greater than C, or in other words, C is less than 24, which means that the maximum is 24. And just barely less than 24. So 24 is the smallest whole number that is larger than C. So now let's look at A plus B is greater than B. We have 5 plus C is greater than 19, which means C is greater than 14, but also C can't be bigger than 24 because of this first inequality, so the maximum is still slightly less than 24. And finally, we have 19 plus C is greater than 5, and this means that C is greater than negative 14, which is obviously true because C is a length. So we know that the smallest whole number greater than C is 24. But we need to look back at the question. Even though 24 is an answer choice, we need to remember that we're trying to find the smallest whole number larger than the perimeter of any triangle. So we know that 24 is the smallest whole number that's larger than C. So that means that the smallest whole number greater than the perimeter is just going to be A, which is 5, B, which is 19, plus 24, which is equal to 48. And we can see this by actually using an inequality in terms of C. So we know that C is less than 24, which means that 5 plus C is less than 29, and that also means that 5 plus 19 plus C is less than 48, and this expression is actually the perimeter which means that this is the smallest number greater than the perimeter. And going back to our choices, we see that the answer is choice D, number 48, and we are done. Thank you so much for watching this video. Please don't forget to like, share, and subscribe, and see you next time.